Okay, today we start Markov chains. And Markov chains are kind of a way of predicting future probabilities. I know several of you came across it in IAs. Um, so, and they're going to use matrices. So I want you to watch this introduction to Markov chains. Pause this video and watch that. Okay. Now that you've watched that, representation of probabilities with transition matrices allows us to use current conditions to efficiently predict long-term outcomes. As you have inevitably noticed, mathematics is built upon itself conceptually. Lower-level axioms provide the basis upon which more complex mathematics and subsequent axioms are built. This methodology gives math its epistemic clout. To what extent are other areas of knowledge built in similar fashions? Think about this. If you were to rank areas of knowledge in terms of validity of knowledge produced, would the most axiomatic AOKs be at the top of your list? Depends on what you think. Think about how you would do that. There isn't a right or wrong answer to this. And the knowledge question that goes with this, to what extent is new knowledge a result of prior knowledge? Some tidbits to think about from theory of knowledge. So, conditional probability. So here we have a tree diagram. We've got today's weather is either sunny or rainy. If it's sunny, there's a 65% chance that it's sunny and a 35% chance that it's rainy tomorrow. If it's rainy, there's a 30% chance that it's sunny tomorrow and a 70% chance that it's rainy. So the probability of sunny tomorrow given sunny today is 65%. Remember this given bar. The probability of sunny tomorrow given rainy today is 30%. And those are conditional probabilities. This given part, they don't bother giving us the probabilities for what today's weather is because, well, today's weather is what you could see outside, usually. This is for some area of the country. Definitely doesn't seem like Idaho. Those probabilities, or at least not summer in Idaho. Those probabilities for sunny seem too low. So transition matrices, we can have today's weather, and they do on top tomorrow's weather, sunny, rainy. This should be rainy here. So if today's weather is sunny, there's a 65% chance that it's sunny tomorrow, and a 35% chance that it's rainy. Today's weather is rainy, there's a 30% chance. And they like to do in this book, and I think you can do it either way. Dylan came across doing it another way. Current state. That's why it's today. Future state. This way. That's why tomorrow is there. And transition matrices allow us this thing. And you've done a little bit with transition matrices before. The beautiful part, once we put it in a matrix, we can do lots of operations, like square it to get the probabilities for 2 days from now's weather. So I want you guys to pause this and actually do this. Square it by hand, then cube by calculator, and then describe the meaning. Okay. I'm going to pause the video and then I'll show some of these. Okay, so coming back, now that you guys have done this, we take our matrix, we square it, so we're multiplying it by itself. Remember, row 1 times column 1 gives me place 1. Row 2 times column 1 gives me this one. Row 1 times column 2 gives me that, and then row 2 times column 2 gives me the last one. So, and these probabilities, if you just did the tree again, you would get the same thing. We can do it on the graphing calculator. So those probabilities are like if you tag this, okay, today's sunny, today's rainy, rainy was 0.3 plus 0.7, sunny. So I'm applying the sunny and the rainy states to each one. And if I multiply this out, I get 0.65 times 0.65. Probability today is sunny, tomorrow will be sunny. This is then 0.35 times 0.3, or 2 days from now. So if today is sunny, I would have to then add these two, which is exactly what I did in the matrix. If today is sunny, the probability that it will be rainy 2 days from now. Again, this is also what I did in the matrix. So adding those two together, or the rainy states. And this, the matrices is just a nice quick way of doing this. Doing t cubed, let's do it on the calculator. Remember, I click this button next to 9. I enter my t. One handy trick for this is to store it. I think we did this a little bit when we did them with adjacency matrices, but store it. Then when I want a cube, I just do t cubed. I don't have to re-enter it or copy and paste. So this gives me today's sunny, the probability of it being sunny in 3 days is 0.48. Probability of it being rainy in 3 days is 0.515 or 0.52. Probability, if it's rainy, the probability that it's going to be rainy is 0.5582. So what does this mean? T to the n, what it asks me about, is the probability that it'll be sunny or rainy based on today's weather after n days. So if it's sunny, the probability will be sunny, and if it's rainy, the probability it will be rainy. So here's another one, different place. This, again, should be here. Apparently they're having typing problems with this book. So if it's sunny, there's a 75% chance it'll be sunny tomorrow, 45% chance it'll be rainy. Notice that we had one where it added to 101, but that was just rounding. That these add to 100%. The current state will always add to 100%. The state for the next doesn't necessarily have to. Okay. So given that it is sunny today, find the probability that it'll be rainy 3 days from now. So I'm going to take this transition matrix and put it into my calculator. It asked me for 3 days from now. And I'm double checking that that's actually right. Okay, yep. And I'm going to start as t again. I don't care about the last one. And 3 days from now is going to be t cubed. So keep in mind, this is r. Today, this is 3 days. It's now 3 days because I've cubed it. And I need to look at what the question asks again because I don't remember. Find the probability it will be rainy 3 days from now. So it's sunny today, rainy 3 days from now. 34.75 or 35%, or 34.8% chance. Probably should do 3 sig figs. This is IB. 34.8% chance it'll be rainy tomorrow. Oh, they gave 4. Transition state diagrams are essentially just graphs with the probability on them. This is a 3 by 3. So notice that A can go either to B, A can go to C, or A can go back to A. And they've got this thing programmed, which is pretty cool, to have the probability that it gets to a certain point to be different, and it's doing it random. So now we've got 3 states: sunny, rainy, cloudy. If it's sunny, there's a 60% chance it'll be sunny tomorrow, 25% chance it'll be cloudy, 15% chance it'll be rainy. If it's cloudy, there's a 30% chance it'll be sunny tomorrow, 35% chance it'll be cloudy, 35% chance it'll be rainy. If it's rainy, there's a 25% chance tomorrow will be sunny, 30% chance cloudy, 45% chance it'll be rainy. So, given this, find the probability it will be sunny in 3 days. Probably the easiest way to do this is just write the matrix, given that it's rainy on a certain day. So we're going to go current, today, tomorrow, sunny, cloudy, rainy. I'm not sure if that's exactly the order they did it in, but it doesn't really matter. Sunny to sunny is 0.6. Sunny to cloudy is 0.25. Sunny to rainy is 0.15. And that does add up to 1. Cloudy to sunny is 0.3. Cloudy to cloudy is 0.35. Cloudy to rainy is 0.35. That also adds to 1. Rainy to sunny is 0.25. Rainy to cloudy is 0.3. Rainy to rainy is 0.45. So I have my matrix. It asked me for 3 days from now, so it's going to be a t cubed type of matrix. So now when I go here, I need to select this 3 by 3. I'm leaving it there so I can still read it. Okay, now I'll clear my drawings. So now I've got my matrix. I don't necessarily need to store this because I'm probably only using it once, but seems worthwhile. And then I'll cube it. I can use answer, or I could enter T again. So now I need to look at I'm going to label it how I labeled it before. So I guess this is 3 days. And then I'll have to look at my question to make sure I answer what it actually asks for. Given a certain day is rainy, find the probability will be sunny in 3 days. So it is rainy, sunny in 3 days, 38.9%, or 38.85. It doesn't specify sig fig, so I'm going with 3. So there we have using transition matrices with Markov chains. And that's your introduction. Tomorrow we'll go into more depth.